Okay, so this is SIG-AWS. Today is June 30th, and we are going to start with introductions. I will go first. I'm Justin. I do a lot of work on on the AWS cloud provider for Kubernetes and on COPS. And I don't know if anyone else wants to jump in. Otherwise, I will start calling you by name.
I'll go next. Yeah, hi there. My name is Arun. I work in the open source team at AWS, and I've started participating in AWS SIG recently.
I'll go next. I'm Chris Hine. I'm a partner solutions architect at AWS as well. So I basically manage all of the container partners.
I'll go now then. So I'm Stuart Williams. I am the Director of Product Management at Weaveworks, and we run our Weave Cloud product on Kubernetes and build stuff that works with Kubernetes.
Hi, I'm Seth. I work at Been Verified. We currently are running a production cluster on AWS using COPS.
Anyone else want to do an introduction of themselves? Yanis, maybe?
Yep. Yeah, sure. Hi, I'm Yanis, based in Berlin. Also working with Zalando sometimes. And we're running 2 production clusters on AWS based on Kubernetes since about autumn last year.
Joe, we're just doing intros if you want to say hi. I'm sure everyone knows.
Hi, I'm Joe at Heptio. And yeah.
Cool. And Max, I don't know if you are new. Max Kai, is that right? If you want to say hello.
Hi, this is Max from Toronto. I'm a DevOps engineer and a cloud engineer. Work for different consulting company right now. And yeah, interested with Kubernetes and COPS and all the Weaver networks.
Last call for introductions, anyone? Okay. Oh, well, I think your sound might be broken anyway.
Sound is broken?
Oh, it's just very quiet.
All
Go
right,
for it.
Yeah, all right. So I'm Rafael from Zalando, Berlin. All right, yeah, we've been doing Kubernetes in production since autumn last year, so September, October, I don't know. Yeah, my dashboard says 25 clusters now.
That's awesome. You need federation.
Yes, we do.
Cool. Well, we have a fairly light agenda today. I think we have a demo from Zalando. I don't see them on here unless anyone will correct me. So, sorry, not from Zalando, from Romana. I'm sorry. You guys didn't prepare a demo? But other than that, I don't know if anyone else has any items they want to throw on the agenda. I suppose the big news is I think 1.7 was released pretty recently. There are a lot of, I guess, relatively small bug fixes in terms of AWS. There were some relatively small bug fixes, particularly as pertains to clusters that are bigger than, I think, 200 or around 200 nodes had some issues which were introduced in 1.6. So those should be addressed in 1.7 for people running clusters of that size. And then there's some functionality which exposes, as I recall, like the ability to tag ELBs and some more magic annotations. But honestly, there's not a lot of churn, I think, at least in the AWS cloud provider, which I think is probably a good thing. I don't know if we want to discuss, I guess we could discuss what people want to see in 1.8. I'll throw that on the agenda as something for the end of the item, for the end of the agenda. I don't know what the state of the cloud controller manager is in terms of it being the official solution, but I expect that either in 1.8 or 1.9 we can expect that the AWS cloud provider will move into a separate component, which should have no user-facing impact. But if you are working on kubeadm or COPS or your own system, you will probably have to be aware of that over the coming 6 months, I guess, if you're not already doing it. I don't know if, is kubeadm already running external cloud controller manager, Joe? No. So there we
I don't believe so. Well, I mean, it's up to you to set it up. I believe, I don't know of anybody doing it yet, right? So kubeadmin default is silent on cloud providers, right? There's some hooks, but it's complex enough in terms of having to sort of get all the sort of stars aligned that we don't try and make it look easy when it's not.
Right. And I think we're all working on trying to make it easier.
Yeah, but I think, at the end of the day, like if you launch a kubeadmin cluster and you don't have the right IAM permissions, right? Like stuff's going to fall over. And even if we make the errors clear, if you don't launch it the right way with like at least a role, you're pretty much like, okay, tear it down and recreate it, right? So there's definitely I think over time, if we really want to make it clear, we can build in sort of extensions for different clouds into kubeadmin and have it actually checked for prereqs also, right? So hey, do I have the right permissions when I'm launching this? Along with guidance and instructions on how to do that. So I don't think anybody's done that work yet, but that would definitely make it easier.
I mean, one of the things that excites me about pulling out the cloud providers is it doesn't even need to be a kubeadm concern anymore, right? It can be like, how do I install the cloud provider add-on?
Yeah, and I'd love to see, I think these things are not as tightly coupled as they probably are right now. Because there's going to be places where you want to take advantage of some cloud functionality, and maybe you're running on-prem, right? But you want to have some sort of I want to persist stuff here into this cloud, so I don't think we sort of view this as one sort of big bag of functionality, and I think it makes sense to sort of split it up a little bit and find other places to be able to use it.
Yeah, I mean, one example that could be like ECR or GCR, the container registries. You could, in theory, I guess, use them externally.
Well, no, GCR is actually really easy to use outside of Google Cloud. ECR, though, is really, I think it's using that outside of EC2, I think, is a real pain in the butt. Last I looked. I don't know.
I think it uses a dynamic Docker password. So
That's right, yeah. So you have to have a thing that's renewing it, and so there's no way.
Kubernetes has that. It's just we need to say that you can enable that when you're on bare metal. If anyone, I haven't heard of anyone asking to do that, but if they did, then we could. That is something we could split out further.
I think I saw there was a project that would auto renew that password for you, but it's not well documented, and it's not clear sort of how well supported it works and all that. So
yeah, and I'd rather we put all the we have that code in Kubernetes, so let's make that code better where if it's not adequate in some way. Anyway.
So I want to understand this issue slightly better. So are you saying that ECR is not easy to use outside Amazon infrastructure?
Yes.
Okay, and what is it that we can do to make it a slightly better experience?
So Arun, the big issue there is around credentials. Right now, the ECR credentials are temporary. And so if you get the right stuff installed when running on EC2, those credentials get renewed whenever you need to. When you're running off of EC2, those credentials tend to expire, and it's very difficult. You have to sort of do a lot of extra plumbing to automatically renew those credentials when you're running off of EC2. And then doing that with Kubernetes ends up being a little bit of a Rube Goldberg type of thing right now, currently.
Okay, fair point. So what I'll do is I'll discuss this with Chris further and see, what is it that we recommend to our customers.
Yeah, I mean, I'm happy to, or I'm sure there's other folks on the call here that'd be happy to sort of give you more context as you dig into it.
Yep, that'll be useful. I have one question on 1.7 though, Justin. So when do we expect COPS to start supporting Kubernetes 1.7 now?
We should do a COPS alpha maybe today, but this weekend-ish. And we typically don't do we take advantage of the fact that we're not in the main repo, so we don't do a gold release on the same day, which I think is the correct call. So we'll do an alpha. If everything is perfect, we would do an alpha around now. We'll do a beta in about a week, and we'll do a release the week after. I think for 1.6, where there were some teething issues, it went, I think, I think we pushed them out by like a month or so, or even longer. So but you can expect to see an alpha soon that actually will work, seems to work fine. But that, we do the alpha because we want to indicate to people that there may be problems, because it is a 1.7, it is a .0 release, and they tend to be .Os.
Right. And so what that means is, if we do a 1.7.0 alpha, then if anybody wants to start a Kubernetes 1.7.0 cluster using kops, they will use the Kubernetes version switch for that?
Correct. Yes, we'll probably push it out to the alpha channel as well, so you can do like channel alpha. And I believe that actually, like, even kops 1.6 works fine with Kubernetes 1.7 as well. The changes are not, or there aren't any like massive breaking changes that I've found yet. But we're going to do the 1.7 alpha pretty soon anyway, and that will be where we do the recommended hardening and verification and all of that.
Gotcha. Yeah, feel free to use me or the rest of the channel, of course, as a guinea pig. I'm happy to test it out once you have the alpha ready.
Awesome, thank you.
Yep.
Unless Romana is here, why don't we jump out of order? And Joe, do you want to give us an update on Spiffy Pod Identity AWS?
Yeah. So okay. So for those who aren't familiar, Spiffy is this thing about sort of how do we in a sort of generic reusable way distribute certificates and use them across different workloads for both server certificates and client certificates. There is a discussion ongoing within sort of the group of folks working on Spiffy around how best to use this on Amazon, regardless of whether it's included with Kubernetes or not. And so I think that's interesting to this group. So just a heads up there, looking at ways to establish trust between machines by relying on essentially the AWS control plane to bootstrap that trust. Looking at things like the identity document, how much does that really tell you? I think Vault does some interesting stuff around giving you a nonce, and then you use that to essentially use a role so that you can verify that you have access to a role. And then when that thing comes back, it actually says, here's the instance that you're on. And so there's some like weird ways that you can essentially take a piece of information, then sign it with a way where you can trust that it actually came from a certain machine. And so we're looking at how can we actually build that into Spiffy. And then there's definitely overlap with building this into the built-in CA for Kubernetes for establishing bidirectional trust there. And so there's also been conversations within SIG-Auth around, okay, I want to sort of, join a cluster. Is there some sort of AWS specific information that I can give as I sort of propose myself to join a cluster that makes it more confident for folks to auto approve that request? So nothing concrete there, just sort of a heads up that there's sort of, action going on here and interesting discussions. And if you want to dig into that more, I can point you in the right direction.
I know there was discussion of a pod identity working subgroup, not SIG, maybe SIG thing.
So Clayton started this, and so the interesting thing here is this is pod identity, and I actually think that's part of the problem here. So that there's also, how do I know which pod I'm calling from and which pod I'm calling to? How do we map that through services? But then there's the question of how do we establish trust and identity for actually the control plane itself, right? And so there's definitely some shared problems across these things. But pod identity at the end of the day is only going to be as good as control plane trust, right? And so the root of the sort of trust tree here really starts and ends with getting Kubernetes up in a trusted way. And so there's an opportunity here for us to take advantage of some, AWS specific magic to make it easier to build a trusted set of components, trusted cluster.
Yeah, I mean, I think that the ability to access an IAM role is certainly, as I understand it, like the canonical way you do it. So you would have something that you can only access from a particular role. Like, for example, a KMS key. It just feels like a massive, like, I'd say Rube Goldberg machine where you're like, I'm going to create a secret, and like when I access the secret, then I can do things. But it's not terrible, I think.
Well, I think the problem is that right now in Amazon, roles are too chunky. it's not practical to create a role per instance. And so you can use roles in KMS to actually verify that an instance is part of a particular group, which is definitely good, but you can't use it to actually prove an instance is actually that instance. And like I said, I think there was some stuff, it's new since last I looked at it. I was talking to somebody and they were talking about it that Vault does in terms of using oh gosh, I'm trying to remember the
signed document in the IAM.
The instance identity document. So from the metadata service, you can get the instance identity document and its signature as well.
Right. Well, so the identity document is definitely part of the puzzle. The problem with the identity document is that it's not specific to a regular request, so you can hand it off, right? So if you can get the identity document, you can present it to somebody else and impersonate it. The ideal thing here would be to have a metadata service where you hand it some sort of nonce, and then it creates an identity document with that embedded in that for you, right? Because if you could do that, now you could actually say it's a challenge response. This is actually very specific to, and you could bind that into things like, say, the Acme protocol for essentially establishing who you are.
Yeah, this is kind of similar what Vault is doing as well. Yes, exactly. So we use something similar so we have our own Docker registry, and we want to know, so it's only internal, but we want to know who can pull from this registry and not push. And we use the instance identity document for this kind of authentication, because it's like, at least we know it's one instances, and we just check that the account, so the information contained in the document is actually something that it's one of our account, is still active, and this kind of stuff. And so, but you're right. So Vault does something more, and we need something more in this case.
Yeah, and so I think, again, it's like, security and trust is never binary, and so having the identity document is a plus, right? It's better than not having it, right? But it's not, it's not as sort of verifiable as you probably would want. Yeah.
At least on AWS, my understanding is that IP addresses are not spoofable. Although maybe that's not true if you turn off source desk checks, but I'm not entirely sure. But there may be it may be that we have to do something AWS sort of specific, and I don't know if I would love to find the magic bullet that works that doesn't require IP address trust or anything AWS specific, but it might be that we just have to accept that you have certain pieces of evidence and you add them up and.
Yeah, and I mean, and some of this, I hesitate to call it security theater, but at some point, if you don't trust your cloud provider, you're kind of screwed, right? It's like, at the end of the day, they can scrape memory out of your VM and find keys that way, right? It's like, there are sort of new features coming with, new Intel virtualization modes with protective enclaves and stuff like that, where you are actually protected from the cloud provider to a deeper way. But I think there are cases where, there are advanced cases where, where you can spoof the IP address. At least I know on GCE, and I assume that those same scenarios play out in EC2 also.
EC2 does not allow for IP spoofing. We played around with that.
Well, you said the source desk, the source IP checks, right? You can turn it off, right?
Yeah, and I'm not sure exactly what that does and does not do.
So I think that's necessary for doing the NAT gateways.
Not NAT gateways, but for our Kubernetes style stuff. Oh,
yeah. So essentially
a NAT instant, I know.
Anytime where you want a VM to act as a router, you need to be able to essentially, represent a subnet and external subnet, and you need to be able to do some funky things with source IPs.
So if we want to learn more about this, where is this discussion happening in regards to the bigger picture?
It's a diffuse discussion, so I think probably the pod identity is going to drag in a lot of this stuff. The spiffy stuff is percolating along. I think they're bringing in folks who are sort of, have a little bit of time to really dig into that. If you want an intro to some of the folks there, just drop me a line. I'll put my email in the chat here, and I can definitely get you at least do an intro there. But yeah, it's kind of one of these things where it percolates along for a while, and there's a big soup of ideas, and I think, you know, over time it'll be distilled into something. But it's starting to bubble. Maybe as the soup is starting to bubble.
Is the pod identity group, like, is there a mailing list, or where is that held?
Oh, let me dig that up real quick.
I heard talk of it, but no actual, like, you know, stuff.
God, somebody just like, okay, now I'm looking in mail. Now I'm gonna look in Slack. I think.
When is a bi-directional Slack to email gateway, and then we can just turn off Slack.
All right, I'll look at it. I'll put something, if I can find something, I'll put it in the chat while we're talking about other stuff.
Sounds great. I don't see anyone from Romana that has joined. I have pinged them, but let's continue with, unless anyone has any other business, should we talk about what people would like to see in 1.8? What are people's sort of biggest pain points right now? What people might want to work on? That sort of, anyone want to volunteer anything that they are working on? I can kick us off, which is Kube to IAM obviously remains something which we want to do, and I'm sure, given my hammering on pod identity, that people have figured out that I think that they're very related, and so that is,
they're definitely very related.
Yes. So yeah, getting that working and getting that nicely working, I think would be a big. Maybe we can finally do it in 1.8. So that's going to be something I'm working on. Let me put that in the notes. If anyone else has anything that they are.
I think there's this chicken and egg thing, honestly, and this is the unfortunate thing of, like, if all this pod identity stuff were done, then the IAM stuff would be really straightforward. I'm not going to say easy, but straightforward. Is it worth waiting for that versus doing something that's more one-off? I don't know.
I mean, I think there are the two things I would say is there are a lot of people that are using Kube to IAM today successfully, and we want to continue to give them a path. Give them a path. And then the other thing is, I think, you know, there's the danger of, like, retreating into the ivory tower. And so if we use pod identity and say, like, how do we make Kube to IAM and other things like it work in this scenario, then I think that would be helpful for everyone.
Yeah, no, I think if folks are getting value right now, let's not leave them in the cold.
And I think the design is correct. Like, I think we've talked about it, and, like, we've talked about, you know, should we automatically create roles and the implications of that in terms of security. And it seems like the Kube to IAM design is basically spot on. So, like, some debate about whether you want to run it on every node or whether you want to forward it, but other than that, that requires some notion of identity. So basically, like, the big picture design is exactly what we would build, even if we started from scratch, knowing everything. So it seems like a good approach. Anyone else want to throw in anything they are working on? Maybe not even related to AWS, or?
Is COPS compatible right now with the 1.7 release, or is there anything that needs to get done for that?
COPS 1.6 should work with Kubernetes 1.7. There's a series of PRs that are going through the process right now where we're doing, like, we're bringing up, like, bumping the versions of everything to the Kubernetes 1.7 version, which will be important for API machinery type things. Bumping, like, the kube DNS version. But I haven't really looked at, like, some of the more advanced features in 1.7, like the node security policy type things, and whether we probably still have to implement whatever we need to do for those. Okay. That certainly is not in COPS 1.6 if it requires additional flags. But I don't think there's a huge amount of new stuff in Kubernetes 1.7 other than, like, hardening and general fixing. So I think it's a more stable release, more like incremental release. Okay.
So I did dig up the email message that was sent to SIG-AWS around the working group, and there's a doc linked off of there. I think if you're in Kubernetes Dev, you have access to the doc, because people with G Suite orgs and documents that they can't share publicly and all that. And so definitely something interesting to get involved in there.
Thanks, Joe. I'll paste that link into our minutes, I guess. Oh, I'll try to.
And it wasn't Slack. That's where I found it.
I think Romana is joining now. Let's see. And actually, do we want to? External DNS seems to be going very well. Do you want to give us a quick update on how that is going in terms of just the AWS support and the other cloud providers? Me? Yeah. Sorry.
Oh, I don't know.
Me?
Yeah, go for it.
Okay, can you guys hear me?
Oh, well, here's Romana. So should we do the Romana demo? Yes, we can, Chris. Go ahead.
Okay, I'm sorry. For some reason, my calendar showed up 10 a.m. I guess maybe with daylight savings or something, it didn't hit me that it was 9 o'clock. And unfortunately, the demo is going to be done by my colleague who is in a different time zone. So we unfortunately may not get a demo right this second. But I have a couple of slides to go through that I was going to go through in advance from the demo. So anyway, so kind of rolling with the situation. So sorry about that. Can I share my screen and we'll begin with that, and maybe Jürgen will show up in time.
That sounds great. Yes, I mean this is something that's interesting in terms of the routing table limits, and I think it would be great to see how you.
Sure. Yeah. Let me share my screen. Okay. Okay, can you see that?
I can see it at least, yes.
Okay, good. All right, well, hopefully Jürgen will show up to actually give a live demo, but short of that, I can explain exactly what we've done and how it all works. So let me jump into that, and I'll go through this pretty quickly. I think probably everybody here is very familiar with the problem, so I'm not going to spend a lot of time on that. But just to recap, there's a limitation in the VPC route table that limits cluster sizes, and perhaps one that's not something you are very much aware of, but if you run a CNI network provider, that requires an overlay when you go across zones. So for HA clusters, you can't apply network policy. So these are two things that we've been working on, and our next version of software, our next version of Romana, addresses both of these. And we set out to do this with these following goals. We wanted to use all standard APIs. We didn't use annotations or third-party resources. We wanted to use all of available VPC routes that are there today, but enable large clusters without an overlay. And then for HA clusters, support the network policy API. So just to level set, that's what this will provide. So it's part of Romana version 2, which is not yet available. And the big features there are topology-aware IPAM and network advertisement. And what I'm going to show today is there actually the idea of advertising the networks into the VPC routing table. So that's kind of what this new software does, this VPC router that we called. And that's going to be ready sometime next month, okay? So anyway, this is a VPC router for EC2. It's up on GitHub, and I'll go through how it all works, and hopefully Jürgen will show up to give a live demo. All right, so here is a standard EC2 VPC with 3 availability zones with 3 hosts in each. Okay, so we've got 9 instances, and you're familiar with how this all works. We've got a /24 in each zone, and then each host pulls an IP out of that block and then runs on the VPC network. Okay, so that's all very standard vanilla stuff. But we solve this by introducing this concept called a prefix group. Now, the user is not going to be exposed to a prefix group. This all happens under the covers. But essentially what this allows us to do is ensure that pods get IP addresses from within the prefix group, okay? And it does that through its new IPAM, all right? So this is the first new concept that we introduce, and I'm going to go through a very simple example, and then we'll go through a more specific example of how this is deployed. So you see here we have this prefix group, and the pods that get launched are going to live within that prefix group. So that's all standard Kubernetes pod networking. Okay, so now on the master, now Ramon has got its own services that are running on the master, but there's this new service that's part of that we call the VPC router. It's going to run, one instance is going to run on every master, and since there's a master in each zone, there's probably going to be 3 of these. Okay, so that's how that's going to be deployed. And the way this gets configured is it's going to identify one of the running instances in each zone to be a router to forward incoming traffic to that zone to the ultimate host that's running the pod. Okay? So that's what VPC router does. So now what happens here, important, VPC router is going to set a route in the route table, not for every instance, but for every prefix group. Okay, now that's how it aggregates routes, and that's how it saves the entries in the route table. Okay, now you can have lots and lots of prefix groups. You can have as many prefix groups as you have instances, so this falls back to the KubeNet model. But again, and fundamentally, the issue here, the way we conserve routes is by using a VPC route for each of these prefix groups, okay? So then operationally, also, there's also health checks. So VPC router checks the status of that instance and will update the VPC route table to point to a live instance to forward that traffic, okay? So at the end of the day, what happens is once these routes are set in the VPC route table, a pod that's living in zone 1 that needs to talk to a pod living in zone 3 is going to send directly to its pod network IP address. The traffic's going to go out through the default route, but it's going to pick up the route in the VPC routing table to be forwarded to the instance in the availability zone 3, and then that instance, which case is 168.3.2, the instance is then going to forward that traffic to the pod that's actually running, to the host that's actually running the pod, okay? So that's what it does. And okay, so now, as I said, so this is to overcome the 50 route VPC limit. So again, we only set the routes for the number of, there's only one route per prefix group, okay? All right, so that example was one where you had a prefix group per zone, okay? But we also wanted to support the simple case where it replicates KubeNet's capabilities. So what that would require would be to simply identify each host to be its own prefix group, okay? Now again, this all happens behind the scenes. The user isn't exposed to any of this prefix group stuff. But the end result is that in this case, the VPC router software that I just described would actually put a route in the route table for every EC2 instance. And again, that's the KubeNet model. Now, one other final point to note here is that the way Romana typically works in layer 2 environments is that it actually installs installs routes on each host. So when clusters are deployed in layer 2 environments, there's no external routing necessary. So in the case where a cluster is within a single availability zone, there are no VPC routes required at all because the routes are installed on the host, and that's sort of the standard Romana mechanism to forward traffic. Okay. All right. Now, what time is it now? Unfortunately, we will not be able to get to a demo till 10 o'clock. But what we were going to show, and if we have time, we can get to this. It was a live cluster running 12 nodes in 3 zones, where VPC router is running in one of them. And what we're going to show, and it's kind of embarrassing, we're not going to be able to do this without Jürgen, was exactly what I described there. Basically, we can show a trace route to from a pod to a pod across zones, and then just show that route changing as an instance gets killed. So it provides the failover mechanism to update the VPC route table to do that automatically. But also you'd see that the routes are in fact aggregated. You see here the routes here are for the entire pod subnet. I'm sorry. The route to all the traffic on the subnet goes to a particular instance in that node, not to all the nodes. There's not a route for each node. So that's what I described previously. There is a route entry for each prefix group. So that's, at this point I was going to show the demo, but unfortunately I got nothing but sort of shadow puppets. So guys, if Jürgen shows up, he can do that. But at that point, I'm afraid I got nothing. So sorry about that, guys. It's a little embarrassing.
Well, I think that was great. I mean, I certainly got the idea. I don't know if anyone else has any immediate questions about how it works. I think it's clever. I think it's certainly very interesting to keep the kubenet model, basically extend the kubenet model past the VPC routing limit by using nodes as automatic router promotions and like that. I'd love to see, I'm looking forward to seeing it when it is available. It sounds like the source code is available now.
Yes, well, there's a couple things. So the VPC router software is available now. And actually you can, play around with that at the command line to see how it wiggles the VPC route table directly. But to actually deliver what I described actually requires, integration with Kubernetes to pick up etcd data, and Romana's IPAM works in conjunction with that. So there's sort of, interdependencies ultimately to deliver what I described. And that's going to show up in Romana 2.0 in a couple of weeks. But the route manipulation software, VPC router, that's a standalone thing. You can pull it down and play around with that at the command line to your heart's delight. But again, it's not going to deliver what I showed unless it has all the other apparatus around it.
And I think something that I think is coming up on a lot of people's radar is being able to span I guess regions or between clusters. I don't know if Federation yet has a great story for a stateful set of Cassandra, or of a MySQL replica. How do you actually communicate between the two nodes if they're in different clusters or in different regions or whatever? And it looks like as it stands today, it doesn't do that, but maybe it could be adapted. And I know
correct.
I know
It could be. It absolutely could be. But let me sort of back up a step and sort of share some perspective that we've gained over time here. We've got a bunch of users that are running clusters in separate regions. And sort of that has informed our design choices here. And what we have found when they split across zones within a VPC, they do not want to be bothered with the hassle of running a Quagga instance and all that other networking, mumbo jumbo. They said, F that. I want to use native networking. I will let a node forward traffic. I'll introduce an extra router hop on a subnet in a zone, and I can live with that. However, when they go to multiple VPCs that are living in multiple regions, they're invariably forced out into the public internet. Not invariably, but frequently forced out into the public internet. And at that point, they sort of bite the bullet and say, well, I need to take care of all the other stuff. I got to backhaul it into my data center. At that point, they sort of cross the threshold where they say, I'm going to run Quagga because I need all this other stuff. So we decided that was territory that we just didn't want to get into just yet, although we could. There's sort of a bright line between those kind of deployments and the ones that we were focused on initially, where you had HA clusters across zones in a single VPC. And there's sort of a step function when you get to the networking complexity on how you want to go across regions. And again, that's where Quagga, actually does a pretty good job, because there's a lot of other requirements that it can accommodate, and sort of a little beyond the scope of what we want Ramana to do right now. But anyway, perhaps longer answer to your question, Justin, but that, again, is sort of the perspective that we've been hearing from some of our users.
That's awesome. Anyone else has any? Joe?
Yeah, so I mean, so the VPC router then, it updates and modifies the AWS route table, right?
Yep.
And then is there a local component running on the node that actually installs and manages the routes by essentially monitoring the other nodes? Okay.
Yes, well, that's vanilla Ramana. That was Ramana version 1. So we had a CNI plugin and a Ramana agent that communicated with our Ramana services that, was part of it, fetched the Kubernetes API. So that mechanism is sort of existing machinery.
Okay.
And now there's this new piece that is adjacent to it that, well, let me back up a further step here. So with Ramana version 2, what we're adding is the ability to advertise routes. And that was missing in version 1. And the idea of advertising routes to a top-of-rack switch is sort of like the canonical example of route advertisement. But within VPC, the equivalent is to announce a route to your top-of-rack switch, and VPC route table is conceptually the top-of-rack switch. So since VPC can't, doesn't run OSPF or BGP, we needed something to modify those routes and essentially advertise those routes as though it were a top-of-rack switch. So that is sort of like the functional slot that VPC router fills. It allows you to, on the southbound side, take a route advertisement that we need for all layer 3 deployments. But on the northbound side, there's no BGP listener, so we just talk VPC route APIs. So perhaps a longer answer than you wanted.
No, and then the router that you're running in the to handle sort of incoming cross VPC traffic, right?
Well, that's just IP tables. That's just standard.
That's just IP tables. Okay.
That's
okay. And so you designate one node. Okay. So a couple questions is that, can you be more selective in terms of which node that is? And so, like, because just picking one and sort of saying you're it feels very Skype-like.
Yes. Well, so certainly that's a very high priority to get smarter about. Right now, it's quite brute force and rudimentary, but there's obviously that's what's going to come next, because you got different sizes.
Is that a singleton, or is there an ability to essentially have a set of those in case that machine goes down, and for scalability?
No, there absolutely there's a set of those. I wish Jürgen could show you this.
Okay.
But,
so it's really a set of those, and then I guess are VPC routes, are they machine aware? Do they do health checking so that if a machine goes down, they stop sending traffic? Okay. I know GCP supports that. Okay.
And that's that's one of the big problems. They black hole your traffic unless you can update that. And you need an out of band health check.
The care and feeding of those routes to make sure that they, okay. And then the number of routes in the route table is going to be the number of zones, or sort of like times the number of essentially forwarders that you have per zone, right?
Correct. So again, that's when I go back to my earlier point. We introduced this concept of prefix groups.
Right. Okay. So the number of prefix groups times the number of forwarders that are in the prefix group. So you can't run a large array of forwarders there because that'll actually blow out your VPC table.
Right.
Okay.
And there's also a AWS specific limit, as I understand it, which is you can't have two destination CIDRs that are the same going to two different targets. So I think.
Oh, really? Okay.
Correct. So again, it's not routed because they do some funky Mac, shuffling.
Oh man. I'm sorry, I know the GCE stuff well. The GCE stuff is a lot more flexible here. Okay. All right. And so what we really want is IPv6 with big prefixes, right? Okay. I'm just saying that's kind of what we're starting to approximate here, right? You're sort of shifting and doing some replacement on the IP addresses to approximate the fact that we actually have like some bits of IPv6 space. So,
yeah,
okay.
Well, so just as an historical footnote here, the original idea for Romana and using IPAM to solve this problem sort of presumed abundant address space, and that seems to be glacial in its pace. So we're shoehorning everything into v4, but we're sort of creeping down that path. But v6 sort of solves a bunch of things.
Yeah, and said okay, and then the IPAM is per node, right? So it's essentially a local decision to do the IPAM because you already know the prefix that you're doing. But you mentioned IPv. Does that IPAM then have to be recorded into a global database someplace? Because it really shouldn't have to be.
So again, this goes back to how Romana works. I didn't really talk about Romana per se, but it has a fairly sophisticated IPAM that allows you to assign a CIDR block per node per namespace.
Okay.
So that network policy can be applied to that block, and then it can actually add to that block. So they can aggregate the blocks to simplify how IP tables needs to enforce that isolation. So I'm sort of veering off. Into other things, but IPAM is.
So there's not a one-to-one mapping between. There's not necessarily a one-to-one mapping between hosts and blocks within that IP group. Okay.
Not at all.
Okay.
Not at all.
You can slice and dice that. All right. Yeah. All right. So Rune, so here's the feedback. We'd love real IPv6.
and a bigger route table limit.
But real IPv6. I was so excited when it's like, oh, AWS has IPv6. Finally, we'll have a good test bed for developing this stuff and using it. And then it's like, oh, you can have 20 addresses and they're not actually in a clean CIDR block. So suck it up, right? And I'm like, oh, that's not really useful.
There is actually
point taken.
There's also actually something which we haven't done in Kubernetes, which I think is interesting from the networking point of view, which is you can have multiple ENIs, multiple network interfaces on a machine. They can get real IPs. They are not therefore subject to the route limit. So something that could be interesting but would be a hell of a lot of work is to do a ENI per pod model. The limits are just high enough where it works. It's like you can get up to like 20 maybe.
Okay, so what you're talking about is all the problems of the dynamic attach of EBS volumes, but let's break into jail for networking on that too.
Yeah, let's double down. Yeah, there is certainly that aspect. I don't think it solves enough problems that anyone has felt it worthwhile, but I think that is certainly something that is something that I keep looking at and thinking, oh, that would be interesting. And like occasionally people pop up with something that it would solve, but not very often. We have a couple of minutes left.
Yeah.
Well, so Chris, thank you very much.
Hang on a second. So Jürgen, by the way, the reason Jürgen Anyway, it's very early for Jürgen. He's in New Zealand, and he is just popping up now. If you want to stay to the top of the hour, he might show up and give us a quick demo. Is that worth it?
Yeah, I'm here.
Oh, here. Oh, Jürgen. Hey, there you are.
Yeah.
So anyway, Jürgen, I'm sorry I told you 10 o'clock Pacific time. It's 9 o'clock. Anyway, Jürgen, I've been speaking for the past 10 or 15 minutes. Went through slides. Joe and Justin have asked some very thoughtful and informed questions. But I think seeing a demo would really help a lot. So I know we've only got a couple minutes, but Jürgen, you want to
can I suggest what we do instead is we'll finish up with just finishing up any formalities, and then we can keep the meeting going for longer, and we can have the demo for anyone that wants to stick around. That will be recorded anyway, so it will be in the YouTube channel, because I'm sure that some people have like another meeting back to back, and we'll probably have to leave. So if there's anything else that anyone wants to discuss, otherwise we will call the last SIG-AWS meeting of June 2017 to a close and go for the demo. Going once, going twice. All right, let's have a demo, and happy Friday to those that have another meeting to go to.
Okay. Right, well, yeah, sorry I missed all the fun here. I'll have, a demo shouldn't take too long. Let me try to share a screen here. Let me get this going here. So hold on a second. Okay, so what can you see here?
Can
you see the screen?
Console.
All right, good. So if you look at this one here, if I just can maybe quickly show this here. So Chris talked to you about the demo, and he gave you some. He went through these slides here. This is now the actual demo setup we have in front of us. So these are the actual prefix groups and subnets and such. So we can see again we have a small cluster prepared, 12 nodes. They are in 3 subnet groups, in 3 subnets, each one subnet per availability zone. You know, it doesn't have to be that. You can have multiple subnets per availability zone, and you could have multiple prefix groups over the subnets. But here, for simplicity, we have one availability zone, one subnet, one prefix group. So you can see we have a Kubernetes master. We haven't gone through a full HA setup for the demo here. So we have just one master. That's where the VPC router software is running. And we have a couple of instances which were chosen as routers into these prefix groups. And we have these route table entries set here. All right. So if I just shrink this here. So when we look down here, we have our console, and we can see that we have these various instances running, and on VPC we have these route entries. You can see the route entries have been created for these prefixes because of the VPC router. So when we now go and look at what we have in Kubernetes, we have a couple of pods running. We have a sender receiver pods, and you can see their addresses. So for example, you have a sender here in the 112 prefix group, and you can see it is in the 011, it's in the 68.0 subnet on this host here. And we have a receiver, maybe this guy here, who is in the 128.13 host, and you can see it's in a different prefix group. And there are no overlays now running, and if we go now and log into one of these pods, here we go into the sender pod, we can do, let's say, sorry. So we can see we have our own address is 112.1.4. So that is this one here as indicated. And now let's go and maybe connect to a receiver over here in a different prefix group. So as we can imagine, Sorry. I was experimenting with the cluster. So anyway, so we can ping right here, and we can do a trace route. I have this going here, so it basically gives me a refreshing, keep refreshing our trace route display. And so we can see that the packet from this pod makes it through a few hops to get to the target pod. And we can see we can actually see the path of traffic the packet takes. So this is not something hidden by an overlay, for example. So we can see here that this is the first hop is the host on which the sender pod resides. Then this is the host which is currently acting as the router into the prefix group of the target. This is the host on which the target pod resides, and then here's the pod itself. And this is all quite visible in the actual network. You could have network monitors running, and you would be able to see the true traffic as it takes place. Now we have these routes configured here, and the VPC router is monitoring the health of these nodes, for example, of this guy here. So when we go now and take down this instance, I just came online. I'm not quite sure if I might have to log in here again. It may have logged me out overnight. No, it's all good. Okay, so if we take down this node here, it's 112. I believe it is this one here. Let's see. Yes, 108.12. So this we will just stop this instance here, and right now I will stop this. And this always takes a little bit with Amazon. We have seen times where it takes 10 seconds, others where it takes a minute for the host to actually be stopped. So we are here a bit at the mercy of Amazon to see when it comes, when it really stops. And so our VPC router is monitoring the situation in the background. That has stopped. And it should take just a few seconds. Here we go. And now it has failed over. It has selected a different host as router. And now it has happened to have selected the actual target host on which the pod resides. That's coincidence. There are several hosts to choose from. So it has randomly chosen the 128.13 host as a router. And this is exactly the pod on which host on which this pod's running. So we now have one less hop here. But you can see how how we can have now a routed network and no overlays, and even if a host fails, the system keeps running. That is actually the gist of the demo.
That was a great demo, and oh wow, I was gonna say the timings are really impressive, and then I saw that 10 millisecond one pop up there. Oh, what happened there?
Yeah. This IP address was briefly discovered to have failed because the health test that we are doing on the hosts is not particularly well done yet. This is a very early version of the VPC router. It just sends a ping, and sometimes it's well, it works actually. You see it even here. It failed over, and so for some reason it detected this node as down. It isn't actually down because Amazon sometimes swallows the ping packets or lets them delays them a little bit. I found.
Can you do a refresh on the VPC route table, Jürgen, or the other console?
Yeah. So oh, sorry. I need to. This window is really small. Hold on. There we go. So these things will have changed accordingly. So if you look at this this entry will be updated automatically. We didn't now monitor this here, but yeah, you would have seen this this number here has changed.
Yeah. Good. It worked. I'm glad you showed up at the last minute there. A bit of a diving catch for the demo, but
Yes.
I'm glad that worked.
That's great. And
So
the latency times are impressive. Like, so within a AZ, it's It seems like it's less than a millisecond. And then is it a millisecond across AZs? Is that like a ballpark?
Yeah, that's just, this is. I mean, I think it depends very much on the availability zones and the regions you are in, and what the load is on the networks. All these vagaries that we are used to with networking in AWS. But yeah, this is about the time. You can see that hopping over to another host, and then compared to the like this time here in this row, right? This is a hop over to another availability zone. This was here the additional hop in there, and this is then actually getting to the target pod. And you can see that these sites are times are almost identical. So the additional hopping around we're doing there has hardly any impact really on the ping times, on the latency times. So what we currently have in our demo setup, if I can just go back to the slides here for a brief moment, I just want to stress this. What we have here in this demo setup is we have one subnet per AZ and then one prefix group per subnet. And as I mentioned earlier, that's not even necessary that you do it just like that, because currently you have one host as the target router for, hold on, I could do this. Yeah, we have one host as the target router for all the traffic that goes into the subnet. But what we will have in the 2.0 version is the ability to basically to pre-create a whole bunch of prefix groups that all happening automatically, so that doesn't have to be dealt with by the user, so that the first, let's say, 8 hosts that you add into a availability zone over there will all have their own in their own prefix group, so the traffic gets directly to them, and only then when you go over that in size will these prefix groups then begin to be populated, so that the traffic in between subnet groups actually is not just handled by one host, it can be handled by multiple hosts. So you don't have this a single point of failure, you do have the, so there's no bottleneck, and you do have the automatic failover into other hosts as well.
We saw a failover though, and it did seem to be a matter of seconds, not a matter of minutes.
Yes.
But I would have like.
Absolutely. So this is a very this is an active sort of ping health check. I want to make this configurable so that you can maybe get the state of nodes from somewhere. You can maybe integrate with CloudWatch events if a node goes down. This right now is just the very first version. I mean, already is working, but it's the first version right now where we're just having just the active health checks.
And it took like less than 5 seconds, right? It seemed like it was that.
Yeah. So usually the detection, because we're currently doing the test like once a second actually, the detection happens very quickly, but then you have to send the updated route over to the VPC route table, and that there's always this latency dealing with the API, and by the time it takes effect, a few seconds elapse. Yeah. So, but it is around 5. We have seen 5 to 7 seconds roughly, usually detection time. If you have different health monitoring methods implemented, then there might be more or less delay based on the health monitoring as well. This right now is once a second to ping, and then with everything together, the actual change 5 to 7 seconds.
That's very impressive. It's great.
Thank you.
Okay. Well, that's all there is today. Happy to come back and do it again, Justin. So thanks for the invitation. Appreciate the time from your SIG. So
Sri, I saw you unmute. I don't know if you were trying to say something, but we couldn't hear you, I'm afraid. If you were.
Am I muted? Am I muted?
Sure, another person was.
Oh.
But anyway, no, that was wonderful. Thank you, Chris, and thank you, Jürgen, and thank you, Romana. That's great. And yeah, if anyone has a question, fire away. Otherwise, we will hold the SIG-AWS meeting to a close.
Thanks. Okay. Bye-bye.
Thank you. Bye.